I cut off there, I apologize. But what I was saying is that if you can draw a line, if, like pretend you're holding a ruler, or you can even use your hand or finger. If you're crossing your graph from left to right and you're only hitting one point at a time or one part of the graph at a time, you do have a function. So, like this graph right here, we do have a function because if we were to cross it, we're actually only hitting one part of the line at a time. And then finally, of course, the table is just like an ordered pair, but just set up differently. It's kind of like mapping. You have your x on the left, your y on the left or right. If you can look at each x, -1, 2, 5, 6, and 7, and only see one of those numbers, you have a function. So we do have a function here, okay? Now I want to come back here, all right, and give you the official definition of what a function is. So a function is a relation that assigns each element of the domain exactly one element of the range, which means for every input, for every x, you have exactly one output. You have exactly one y. Okay. You can't repeat your x's. For every x, you have exactly one y. If you have multiple x's that are the same, it's not a function. All right. If I was to keep going here, right now I'm going to teach you about that vertical line test. Here's what I meant by that. The vertical line test is a visual method using to determine whether a relation represents a graph as a function or not. So you can, for instance, this right here, right? For just so you all know, U shapes going left and right is a function. People get that wrong all the time. But from left to right, you do in fact have a function. Okay, this one here is not a function. So I'm hoping you're understanding the difference between those. Okay, vertical line test applies for both discrete and continuous graphs. On the right here, I do have this. A discrete graph is a graph of isolated points, which means it's just literally points. But a continuous graph is what we actually see here when it's continuously going. Okay, it's a graph of points that are connected by a line. You can actually see that line going up. It's smooth. You can actually see a line. Okay, discrete is when you just see points. All right. Okay, now function notation. Function notation is written just like this. Okay, if f is a function and x is an element of the domain, then f of x denotes the output of f. So, for instance, what I mean by this is that you can have f of x. This right here is called f of x. All right, this is our y. The whole thing of the statement f of x is your y. We're just writing it in a different way and using it in a different way. Okay. X is still x. We're just saying the function of x. Okay, so this function, because of each number of shirts ordered independent value, there is exactly one total cost of dependent value associated with it. So we can write this. Originally, it is written as y equals 8x plus 15, where 8 is your slope and 15 is your y-intercept. But we can change this into function notation and write it of using the function name. And so there's going to be times we're going to have multiple functions on our graph, and so we use function notation to kind of help us determine the difference of what line we're looking at. So f of x is the name of this function notation, but x is still your independent variable. Okay, if we're looking down here, the same thing goes, but now instead of just using f and x, we're now using c. So c is the function of s now. All right, c is still the function of s. Now we just say instead of f of x, we just have c of s. Where c is the function name, so c is the function, and s is the independent variable. Okay. In this case, c is the function of s, and then s would be the independent variable. C of s is the dependent variable. I'm going to say that again. S is the independent variable. C of s is the dependent variable. Okay. So you will have a part of your activity where you have to determine what the dependent and independent variables are. But C of s is the dependent variable. Up here, f of x is the dependent variable. X is the independent. S is the independent. I'm hoping that is making sense here. So if I was coming here, the domain for this case, the domain is like your x, your independent variable, would be your domain would be your s, and then your range would be the c of s. Okay, I'm hoping y'all are connecting on that there. Yeah. So if you have any questions, let me know. You can go ahead and start your activity, and hopefully you do okay. I have a worked example here you can also look at in the slides.